We've designed our decision support system around users gassing up their vehicles. We've developed a system called GasUp where users choose when and where to gas up according to the best possible price. We're attempting to get the most miles for your money. The main problem involved with gassing up your car is that oil and gas prices are constantly changing. Prices can also vary location to location depending on the gas station which you choose, and it is really difficult for drivers to know when and where to fill up. Usually drivers tend to just go to the location that they see, fill up their gas, and go on their way. Some external sources we use to gather our data are GasBuddy. This is where users update GasBuddy with local gas prices, and they receive points for doing so. This allows you to get a somewhat up-to-date source for gas prices in your local area for specific gas stations. We also use the Organization of Petroleum Exporting Countries, or OPEC, to get an idea of different oil prices for different time periods. So, for the objective of the DSS, we are informing drivers when and where to fill up. This is done by using GasBuddy to find the cheapest gas prices in an area and predict tomorrow's oil prices to determine if gas should be filled up today or tomorrow. And again, using GasBuddy for the cheapest location. So the main aspects of our DSS is the user interface, our data acquisition, and our artificial neural network. We use the user inputs to get an idea of their location given a city and a province, and also a desired accuracy of the user prediction. This way they can control how long the algorithm takes to run in case they're in a rush, or they can run it to get a really accurate idea of what gas prices will be. We analyze the data by putting it into an artificial neural network. A simple artificial neural network is done with 3 layers: the input layer, the hidden layer, and the output layer. Our input layer consists of historic oil prices collected from the internet using the OPEC data. We use these oil prices to estimate the gas prices, and then we give the user the option to define the number of neurons they wish to use. In the hidden layer, we use Solver to determine the value of the weights. We use the evolutionary method due to the nonlinear nature of oil prices, and the solution is reached after 60 seconds of runtime. The user again controls the number of neurons, improving the accuracy or decreasing the accuracy within the 60-second time frame. We then have the final output layer, where we output the next day's predicted gas price and inform the users if they should purchase gas today or wait until the following day. In the system, we finally output and display the gas price by location in an increasing order. This is all the locations in a user's specified area with the price of the gas, the location of the actual gas station, and the gas station brand name. We also inform the user whether or not they should purchase gas today or wait until tomorrow. And then finally, the user can make their own decision on which gas station they should go to and when they should go to it. Now we have a short demo of our project.
The first thing we do is we launch the GasUp application. Excel will load and the user form will pop up immediately, allowing the user to circumnavigate any difficult issues they might find in the Excel spreadsheet. Then the user must fill in some information. We start with the city and the province or state. Any misinformation entered into the system will result in a notification notifying the user that they should correct any fields that they have mistyped. We then enter the prediction accuracy, which is a number from 1 to 200, which will be the number of neurons used in our AND. For this demonstration, we will use 5. We then click GasUp, and the system starts running. The first step is starting to gather GasBuddy information. This is local gas price information from the city specified from the internet. Once we've acquired the GasBuddy information, it starts iterating through the sub-problems in the AND. This is calculating the optimal weights needed to provide an accurate estimation. We have set the runtime to about 20 seconds to avoid making this demonstration too long. We then stop the runtime, and the system informs us that it has detected a rise in gas prices. We should gas up today. It then provides us with all the local gas stations ordered from lowest price to highest price. As you can see here, the bestest gas station we should go to is the Canadian Tire, where we can get gas for 97.9 cents per liter, and it is on 60 Herb Street West. We can then go down and view all of the local gas stations in Waterloo and decide that maybe if we have something closer, we might actually be better off going there. We then close the user form, which clears all subsequent data, and then we can close the Excel sheet, which can be used again at a different time.
Bam!
In conclusion, we recommend that GasBuddy implement our DSS on their website. This will allow their users to better determine when and where they should fill their gas tanks. To improve our DSS, we should also include the following aspects. We should consider the fuel economy and distance to each location of the gas station. This would ensure the user does not waste gas traveling to the designated location. We could also use data mining techniques to better predict oil prices. Finally, we could also collect historic gas prices to better predict trends. Thank you for listening to our presentation, and remember to use GasUp to get the most miles for your money.